Hi everyone, let's continue with photoelectric effect. Today, quick revision with photoelectric effect with some questions. So, photoelectric effect, everything starting with energy levels. Electrons moving from one energy level to another one. As you see, we have two different types of process. First one, electron is moving from lower level to higher level and taking all energy from system. But second one, electrons moving from higher level of energy, higher level to lower level. And this time, electrons just making energy, release energy. So let's continue. So in this topic, we have these definitions: photoelectric effect, threshold frequency, threshold wavelength, work function, and others. So these definitions, everything we should know, nothing to do. Please try to memorize all of them. So photoelectric effect, this is process, emission or absorption. So threshold frequency, minimum frequency of light needed to go up level. So this is our threshold frequency. We'll give more details in other slides. And wavelength, maximum. Please try to see these differences. Frequency, minimum frequency, but wavelength, maximum wavelength. Wavelength must be shorter than threshold. Normal photon wavelength must be shorter than threshold frequency. Because of that, threshold frequency must be maximum wavelength. All right, these definitions, please try to remember. And let's continue. Yes, we said everything starting with energy levels. So first one, absorption, electrons going up from lower level to higher level. So an energy coming with photon or electrical energy. So just energy is coming with HF. What is H? Planck's constant. It is constant number. H equals 6,63 times 10 to the power of -34. It is constant number. With constant numbers, everything I will show you all in one, everything I will show. And then we have energy and we have metal surface. Okay, we have two different things. First one, coming with energy, we have energy, and this one has energy, this one has frequency and wavelength. And then when you come this side, electron has energy. Just to go up, we have minimum energy. That one is work function, V0. We are calling work function. Also, they can ask during exam. So first one, this is minimum energy to go up. In all definition list, you see work function. Work function is minimum energy to take electrons higher level, from lower level to higher level. So work function equals minimum energy to take electrons from lower to higher. And formula for energy of photon formula is E equals H times F with frequency. This is F, frequency of photon. Okay, we should separate, all right, energy of photon and energy of electrons, so minimum energy, work function. When you want to write formula for work function equals H, still I'm using that Planck's constant here, H times F0. This is minimum frequency. Remember in that list, definition list, minimum frequency, HF0. So we are trying to take this electron from lower level to higher level. To go up, it needs energy. Okay, taking energy from photon. So minimum is work function, and this is energy. This E must be higher than work function. All right. So remember, let's write. We're going to make list here. E must be higher than work function higher than minimum energy. Extra energy will change to kinetic energy. It is coming. We are going to explain that. So E must be more than work function. I hope it is clear now. And then what about this frequency? Frequency also must be higher than threshold frequency. These two done. We should know these two because they can ask you some questions. They can ask you which one, what we need for energy and frequency. Energy and frequency. Energy must be higher than work function, higher than minimum energy. And the frequency must be higher than threshold frequency. And then wavelength is coming. So energy is fine. Work function, you are comparing with that. Frequency with threshold frequency. Energy for photon, frequency for photon, for light, but work function for electron on surface of metal, surface just for electron, let's say it's okay. And the work function is work function. And then threshold frequency, it is minimum frequency for electron. I hope you're all clear. From now, wavelength. Wavelength must be shorter than threshold wavelength. Let's write formula, energy formula with wavelength, hc. What is c? Speed of light. Speed of light, 3 times 10 to the power of 8. Let's use this side. C equals 3 times 10 to the power of 8 meter per second. So hc over lambda is giving you energy of photon. This lambda here, this is wavelength of photon. So this wavelength must be, maybe we can show here, it's supposed to be shorter than minimum wavelength. So work function formula also we can write with wavelength hc over wavelength 0. Yes, remember that. If you are writing formula for work function, wavelength 0, F0 we are using, but formula, energy formula for photon, we are using lambda without 0, frequency, so we also without 0. And remember, wavelength of photon must be shorter than wavelength of electron. Okay, why? Because if you want to take, okay, let's try here. Let's use different color. So wavelength, if it is short, it's fine. It can go and it is fit this side. But just think about that. If you have big one like this, so it will not go inside because it is too long, you know, just to hide. So it's supposed to be short. It's supposed to be small. Oops, sorry. So remember, we are drawing this one. Okay. So we have photon, light is coming to electron. Electron getting that energy go up. So we have this formula for energy. And from now, let's talk about kinetic energy. Okay, let's clear all now. So if you have energy more than work function, what's going to happen? Electron will start. Electron will move. Electron starts moving. So it's going to go up, will move. So we can say energy equals work function plus kinetic energy. All energy, extra energy will change to kinetic energy. So from this formula, we can write kinetic energy, maximum kinetic energy equals energy minus work function. So what was this energy? Energy of photon. And this one is a minimum energy to take electrons up level. I hope it is clear. So you are using this one to get maximum energy. And then they can ask you another question. Calculate velocity of electron. What we can do, you are going to calculate kinetic energy from this formula. And then another formula, you know, kinetic energy formula is equal to maximum equals 1 over 2 times m times v squared. So using this one, this is constant number, mass of electron. And you are getting Vmax from this formula. You can use two steps: energy of photon minus work function, getting Emax, E kinetic energy max, and then kinetic energy, using this kinetic energy to calculate Vmax. All right, this kind of questions they can ask you. We have absorption and emission here. So emission, it means opposite. Now from higher level to lower level. All right, electrons moving, but this time they don't need energy. They are gonna give off energy. Those extra energies, they are producing energy. So energy release, and this is same formula, HF, but we are not busy with work function or F0 wavelength here. Only those energy release, but kinetic energy just going also off. So finally coming to this level, change to work function now. This energy release from this energy level emission here. And then, as you see, showing also here, absorption, electrons going to higher level, emission, electrons going to lower level, from higher to lower. And, okay, anything else to remind here? Nothing else. But this one, not 1 eV. Sometimes energy is given with EV. EV is 1.6 times 10 to the power of negative 19 joules. If you need to convert, for example, some energy of photon given with 2 eV. So you are going to write 2 times 1.6 times 10 to the power of negative 19 joules. And you will say 3.2 times 10 to the power of minus 19 joules. Just like that, you should convert it. All right. Remember that. And I think everything is clear so far. Let's continue with next one. Let's see what else we have. Absorption is fine. Work function, threshold frequency, threshold wavelength, done. Let's continue with next one. Now, talk about colors. So lowest energy level, red color, highest blue color. We see these colors because, and then one more thing we should explain. Let's go back. So to release energy, we are having different colors. First one, absorption. When it is taking energy from system, so what's going on? All temperature of system decreasing. Okay, getting cold and then getting dark because taking all energy from system. Electrons taking all energy from system. Remember that. And then when energy is going down, electrons going down from higher level to lower level, and then produce light. So now it is coming with different colors, and then temperature increasing now, so getting these colors. All right, so from lowest level, red color, highest one is blue color. Just remember these colors also. And other formula, you remember from our topic, we have V equals wavelength times frequency. I'm changing this V by speed of light. C equals wavelength times frequency. And then do you remember energy is equal to HF? So for F, I'm writing C over wavelength. Because of that, energy formula, two formula we can write. What is that? What we have, HF or HCF. But same formula for work function. How can I write? Work function is equal to H times F, 0. Remember that? And then work function is equal to H times C over wavelength, 0. This formula in formula box you will have. So we have done. And then what else we have? We have another unit here with A. 1A equals, remember EV with joules. This one is special for length. So 1A equals 10 to the power of negative 10 meters. Sometimes wavelength is given with this unit. Remember that wavelength is given with that unit. And we have some other units. I hope you remember those units because okay, this one not just for wavelength. For example, 1 millimeter is equal to 10 to the power of negative 3 meters. These units we should remember. Or they can give you 1 milliampere, 10 to the power of negative 3A. Or 1 millicoulomb, 10 to the power of negative 3 coulombs. You know that, right? So milli, 10 to the power of negative 3. And then same stuff with micro. Next one is micro. Micrometer equals 10 to the power of negative 6 meters. 1 microcoulomb, 10 to the power of negative 6 coulombs, and then nanocoulombs, NC or NM, it's fine. So 10 to the power of negative 9. Maybe picocoulombs they can ask, 1 PM or PC, 10 to the power of negative 12 coulombs. All right, so remember we said extra energy is changed to kinetic energy. So E equals work function plus kinetic energy. You know that. So E is hc over lambda, you can write. Hc over lambda equals Ek plus work function. So just differences is giving you energy minus work function is giving you kinetic energy. Kinetic energy, other formula, we done already that, 1 over 2 times m times v squared. So you can calculate velocity by using these two formulas. All right, let's continue with next one. I hope everything is clear. So quick revision we said, because of that, quickly let's explain everything and then let's ask you some questions. Let's try. It is formula box from past papers, from last year's past paper. So this formula is given. This one is given. But they didn't give you C equals F times wavelength, but we can write that formula, just change by speed of light. Period equals 1 over F, and this is from Doppler effect because they put them all together. E equals HF is equal to HC over lambda, and work energy formula here, energy work function kinetic energy, and then kinetic energy formula also given. All right, all from formula box. When you see, remember, m is constant, mass of acceleration. Sorry, mass of electrons. Mass of acceleration. Okay, yeah, it's here. It's another table. Which one we are going to use for this topic? We are using H, Planck's constant. We didn't write unit last time, just I didn't remember that. But unit is joule times second. And then next one, mass of electron we are using. It is constant number here. And C, speed of light, we are using. Anything else? K for electricity. So charge of electron, maybe we can use, if they have, because today's example, we can use charge of electron. All right, so this is Planck's, this is a photoelectric effect, Planck's constant, everything. And then we can go to questions. We have two different processes. Now, let's see this question, multiple choice question. Light, white light is pass a cold gas. Okay. We have spectrum on the screen. All right. Which one of the following correctly described energy transition of the atom? Type of line spectrum. So this is our question. Please try. If we can just try first and then just remember absorption. Just taking all energy and then change to cold, just temperature decreasing, remember that. And then for absorption, energy just changing from lower to higher energy level. We can show answer now. Our answer is D, because cold gas is showing you temperature decreasing. If temperature decreasing, it means electrons moving from lower to higher level. When they go to higher level, they are taking all energy from system. And then process name is absorption. All right. If it is opposite, so you are going to change emission all done. All right, let's continue with next question. Long questions coming. We separate 10.1, 10.2 from past paper question. And now light is coming, okay, on cathode. So taking electrons, and then question 10.1. In photoelectric effect, we are saying electrons just like particle. Okay, light has particles, so they are asking you nature of light. Let's continue with an answer, nature of light. Light has a particle nature. All right. Because we are, as you see, we are talking about electrons going up, coming down. So particle, we are talking about particle, taking energy and changing their position. So light has a particle. This is question 10.1. 10.2, they're asking to define the term work function. So we should remember, we should know all definitions to get full mark from this question. Work function is minimum energy that can just minimum energy to remove the electrons from lower level to higher level, or just you can use this definition, full definition, write it down from our definition list. Okay, and now calculations. So what is given? Work function is given. To answer, to get good mark, to get nice mark from this paper or any physics question, guys, please write givens with symbols. So has work function something? So first of all, write work function W0 equals 3,42 times 10 to the power of negative 19 joules. With symbol unit, write givens like this, because when you see formula box, you are going to use W0. So you write with symbol. And then what else given? Light of frequency. Light of frequency, F is given, not F0. All right. Remember, we have energy. We have photon, energy of photon or energy of light, and we have on the metal surface electrons. So work function, threshold frequency, F0. But light of frequency is F only. Okay. So F is given. F equals 5,96 times 10 to the power of 14, 8Z. On the question paper, you can just write it like this. All right, please remember, write it down first with symbols. What they ask, calculate the maximum kinetic energy. All right, if you want to try, please stop me and try first. But for practice, guys, we can go to other video lessons, other questions, because we are answering question and answer, question and answer past paper questions. But now quick revision, because of that, we should just carry on. So calculating maximum kinetic energy. How can we calculate? Please stop video and take your time. Please try. You remember from formula box, you can get formula, all formula. And please try first. Let's wait a few seconds to stop video. Yes, okay. So we can carry on. What we are gonna do, guys? E equals EK plus work function, we said, right? We are looking for maximum kinetic energy. So kinetic energy equals E minus work function. Kinetic energy equals, how can I get E up if I know frequency? HF. We know H, Planck's constant, F is given. So minus work function already given. So it is easy. We can just get it. Let's show from memorandum. See, E equals work function plus E max. And then you are just, you are writing all givens. But if you use that way, it's much easier. Like this, EK equals E minus work function. So H times F minus work function. Okay, you can just calculate H we know, F we know, work function we know, and then you are calculating kinetic energy, done. Maybe next time, they can give you another question. Calculate maximum velocity. How can we calculate? What you are going to do? You are going to say EK max equals 1/2 times m times v max square. So we know EK max. So you can say 5 times 3, 2 times 10 to the power of negative 20 equals 1/2 times mass. We know already 9.1, we know just constant number, and V max. So we know everything, only V max you can calculate from this equation. So they can ask you that kind of questions also. So we calculate maximum kinetic energy by using energy of photon and work function. Now we have just some different question. Now they are mixing with electric circuit. Ammeter reading this current 0,012 and calculate minimum number of photon of light to strike from the soul, minimum number of electrons. Yes, we said electrons will go up, will move up, but now they are asking you how many electrons will move up. So for these questions, let's show, you can try first. So, and then time is given also, that time. So we are using QIT formula. QIT. So Q equals I times delta T. You are getting charge. total charge, and number of electrons equals total charge over charge of electron, using that formula to get number of electrons. First of all, we are getting total charge by using QIT. This is just with different formula, photoelectric effect. So electrostatics for questions, electric circuit questions here. Okay, we have done QIT you are using first, and the number of electrons, N equals Q over E. As you see, they mix topics sometimes. And last question for today. And quick revision, we are going to finish. And then please answer more questions, more past paper questions. All right, maybe you can try full past paper questions with all topics, or it's just for this one, for other topics. But please answer past paper questions. So now they're asking you, intensity of incident light is now increased. So how will this change affect reading on ammeter? Asking you how affecting current. So incident light increase means, okay, let's give answer straight. Okay, so their answer is increase, current will increase. Why? More photons strike the surface of the metal per unit time at higher rates. So more photons, more electrons will come. If more electrons coming, increase currents. All right, increase current, more electrons coming. So in intensity increase, current will increase. Okay, we have done our quick revision. I hope it will help you. Please answer more questions, more practice. All right, we need practice. We need to answer more questions, and then you can get good mark. So thank you very much. We have done for today. See you next lesson. Have a nice